Alright, so we're going to look at how we solve these. So we've got, the first thing we identified is that we need to use train rule because we've got a function inside a function, correct? I've identified that u is equal to 2x because that's the thing inside the log. So I'll try to simplify that. The derivative of u with respect to x, du dx is equal to 2, and dy du is equal to 1 over u. As it was before with x, so when it was ln x, dy dx was 1 over x. So now I can just sub that into my chain rule. Du dx is equal to 2, and dy dx is equal to 1 over u. What should I do now? Replace u with 2x. So I've got 2 over 2x, cancel the x's, 1 over x. Cool? Second one, we can follow the same process. What should my u be?
X squared plus 2.
X squared plus 2. What should my function now look like? Du dx equals? Dy du equals? 1 over u. Right, x. It's okay. Right idea. And then over here, I'm just going to use the chain rule in all its forms. Now I know it's a bit baby to write this out every time, but I find it makes sense. If it makes sense, take the time to do it. I can see that they cancel out. I can see where I'm grabbing my values from. Use a simple technique well, and you get yourself out of trouble. 2x times 1 over u, which equals 2x over x squared plus 2. Can I factorise that? Can I do anything with that? Or is that the simplest version of my answer? It's tempting to think we can factorise that because we see lots of x's and lots of 2's, but that's actually, we can't take an x, we can't simplify that anymore, there's no dot. Even if there was, that's not going to help me with x and 2x on top. So that is the simplest version of my equation. Cool? Last one's a bit of a trick. I can do it using the same technique, but I'm actually going to use a different technique. If I'm unsure, what should I do? If I don't know if I can do the technique or not, my new technique, just go with the one that works. This works all the time. Right? So if you're ever in doubt and you're sitting in an exam, trust me, it's worth doing the technique you know. But this will simplify your procedure. Can anyone see what I could potentially do with that square root? What is that really? X to the power of a half. So this is the same as ln x to the power of a half. Can anyone see what I might be able to do with that? Because I can take it to the front. Okay? So this becomes 1 on 2 ln x. What's the derivative of ln x? Do I have to worry about the half or not? It just stays at the front, it's a multiplier now, correct? It's just a coefficient. So if I've gotten this, I should have, my working's a bit off here. But if I want dy dx, I don't even need to use the chain rule here. Because I don't need to worry about the half, it just stays at the front, and I multiply it by whatever my derivative is. Which is just 1 on x, correct? Which is 1 on 2x. Now if I was to use the chain rule, I'd get the same answer, it would just be a little bit longer. U would equal x to the power of a half, du dx would equal 1 on 2 square root x, y would equal ln u, correct? Mm-hmm. 1 on u. My u, so that's dy dx u. Dy dx would equal 1 on 2 root x times 1 on u. Alright. 1 on root x. What's root x times root x on the bottom? So that would just equal 1 on 2x. Happy with that? Same result, just a little bit more working. Cool? So definitely, if it's already in the format where it's a coefficient, would I be bringing it up? No, I'd just be leaving it at the front as a coefficient. Cool? Just be aware of that. Can make your life a lot easier. I do want to highlight, there is a question in the working that I'm about to set, where, I'll just tilt the camera a little bit. Oh, we don't do the first one, we've done the first one. There's a question in the work that we're about to go, that some of us are about to go through, that has ln 4x squared. And someone did this in the earlier class. They went ln 2 4x. And they got the wrong answer. Why? They've taken the square out of the 2, which is fine. What have they not done, but? They've ignored the fact that they have to. So what should this really read? It shouldn't be 4, it should be?
8.
Not 8. 2. Why does it need to be 2? Because when you take the squared out, you have to square root both terms. Because essentially you're square rooting x squared, aren't you? Because you're taking the square out. So if you're going to have a square root up here, you've got to take the square out of that, which makes it 2. And then if you put the square back in, you get 4x squared. So that's one of those situations where if I was unsure, what would I do? I'm like, oh, I don't know what I'm doing. I know this could be wrong. Let's just go to my chain rule. I know that works for certain. It's worth the extra minute of your working to get the right answer than to take the shortcut. As we get further through, a shortcut will unveil itself, but I'm not going to show you because shortcuts are for those who know the way, and we do not know the way yet. Cool? So let's rip in. If you are up to that stage, I'll put the Google Classroom to work out for lesson 1, lesson 2, and if you're still on your Education Perfect, charge through to Education Perfect.